In this video, I'm going to answer the question, why does the log of a quotient, m divided by n in this case, equal the difference of two separate logs? What it comes down to is the relationship between logs and exponentials. It's crucial. If you look at the definition of logarithms, they actually define logarithms in a way that relates them to exponentials. It's crucial to understand that. And then there's also an exponential property that you will use, and should have used before seeing this, that says that if you take a base to a power, divide it by that same base to another power, you then will get the result, which is the base to the numerator power minus the denominator power. An example, if you did like x cubed divided by x squared, the answer to that is x to the 3 minus 2, or first power. You've done this before, and we're going to use that exponential fact and the definition of logs that relates it to exponentials to show that this log rule actually works. So let's get a couple of things down here. I want to start out by just letting a couple of things be equal to something just to make this nicer as we go through the process. So I'm going to let x equal the log base b of m. And using the definition of logs, you have to remember a log gives you a power. The whole answer to a log is always going to be a power. And more importantly, it's the power needed to get that base, in this case b, to be equal to the argument, which is m. So knowing that the log equals the power, I'm going to have that base raised to the x power equal to m when I convert it over to exponential form. And I'm also going to just bring this in using the same idea. I'm going to let y equal the log base b of n, and by definition that means that b to the y power will equal n. The other property that I'm going to bring in here that we're going to need, that's going to allow us to go from division to subtraction, is this idea that b to the y, actually I'm going to do it this way, b to the x, divided by b to the y will equal b to the x minus y power. So with those facts, I can show why that log rule works. And let's go ahead and get this into play here. So I'm going to start out with the left side, and we're just going to work all the way across until we get to the right side. So start out with this log base b of m divided by n. And then I'm going to use these exponential relations to the logs, and more importantly the fact that m is equal to b to the x and n is equal to b to the y. And this is where the magic happens. I've got that b to the x over b to the y, and I'm going to use this exponential property, and that's what's going to get this division changed into subtraction. We're going to get subtraction into the mix right here on this step. You're going to see it. So log base b of b to the x minus y now. And this is nice, but if you look up at the property, we don't got the subtraction up in a power. So this is where I need to also remember what the logs mean. This is important. Logs give you powers. Log results give you powers. More importantly, the answer to the log is the power needed to take that base and get the argument. So if I look at the base b and ask myself, what power do I need to raise b to get b to the x minus y power? Let me think about that. It should be x minus y. If you want to take b, raise it to some power, and get b to the x minus y power, you better be raising it to the x minus y power. So the answer to that log is just x minus y. That is the power needed. And now we're almost done. I can just go back over here to what I started with, where I let the x be equal to something, the y be equal to something, and get those somethings in play. So we get this x replaced with log base b of m, and then minus that y replaced with log base b of n. And then if I cut out all that middle crud and just take this far left side, bring it down, and then take that far right side that we ended up with, bring it down, we have now shown y. The log of a quotient is the same thing as a difference of two separate logs. One thing to always keep in mind, the numerator is always positive when you're breaking this down into the subtraction. The numerator always goes first, it's always positive. Denominators in logs are always negative when you are doing the conversion. They get the negative sign in front of them. And that's it. I hope that this helped you and makes it a little easier when you get into all the problems you're going to be doing that use these properties and these rules.